Hello and welcome back to Higher Maths Differentiation. Today we're going to look at the chain rule. The chain rule is a way of differentiating composite functions. So at the moment we've just had sine x or cos x or x cubed or 9x squared. We've been able to differentiate them. We had a lot of practice at doing it. So here we're going to be looking at things like cos of bracket 5x plus pi by 6, or maybe 2x plus 1 in a bracket to the power 7. So when we can use the chain rule to differentiate those functions. So stated simply, differentiate the outer functions, the bracket stays the same, and then multiply by the derivative of the bracket. So let's have a look at this example, then we'll come back to the generalized case up here and discuss that. So y equals cos of or cosine of bracket 5x plus pi by 6, find dy dx. So stated simply, differentiate the outer function. So we're doing cosine of all of this. So the cosine is the outer function. The 5x plus pi by 6 is the inner function. So differentiate the outer function. So differentiate cosine of bracket. We'll go to negative sine of bracket. So it'll be negative sine of 5x plus pi by 6. Then multiply by the derivative of the bracket. Multiplied by d by dx of 5x plus pi by 6. So I've just put a very faint line through this, because if we differentiate 5x plus pi by 6, we will just get 5. So my final answer will be dy dx equals negative 5 sine of 5x plus pi by 6. So let's look at generalizing that. So let's relate it to the example as well. So here the f of x would be the cosine of what's in the bracket. The g of x is the 5x plus pi by 6. So that'll be f dashed of g of x. So the g of x remains the same. The 5x plus pi by 6 will never ever change when we're using the chain rule. The f of g becomes f dashed of g of x. So differentiate cosine, we'll get negative sine, multiplied by the derivative of the bracket. So we have indeed differentiated the bracket there to get the 5. Right, special cases of the chain rule. If we have f of x all to the power n, so for example 2x squared plus 9 to the power n, we can bring the power to the front, reduce the power by 1, and multiply by the derivative of the bracket. So that is just a special case of the chain rule up here. Okay, it's essentially the same thing, but for something in the form bracket to the power n. So let's have a look at an example or two using that. So a function f is defined by f of x equals the square root of 2x squared plus 3x. Find f dashed of x. So first of all, put it into a format that we can differentiate. So we can't be differentiating if we have it in root format. So we go to a fractional index. So it'll be bracket to the 1/2. Now remember, the chain rule says, where is it up here? Here we go. The power multiplies to the front, the bracket stays the same, the power lowers by 1, and everything is multiplied by the derivative of the bracket. So power to the front, reduce the power by 1, 1/2 minus 1 whole is 1/2 minus 2/2, which is negative 1/2. So I have a half bracket to the negative 1/2. This bracket does not change. Multiplied by the derivative of the bracket. Okay. Now what some of you will be thinking is, I can do that in my head. Can I just write down 4x plus 3? You can, but you're much more likely to forget to do this part if you do that. So I would like you guys to always write a half bracket to the minus 1/2 multiplied by d by dx of 2x squared plus 3x. And on the next line, actually differentiate what's in the bracket. And then we're going to rewrite it. So we've got 1/2, so that's 1 over 2, bracket to the negative 1/2, so we can move that onto the denominator and make it square root, multiplied by 4x plus 3, so that 4x plus 3 will stay on the top of the fraction. That will remain as the numerator. Okay, so bracket to the power n will be n bracket to the n minus 1 multiplied by the derivative of the bracket. Always put this bit in, or there's a good chance you will actually forget to do it. So train yourself up to do it properly now, and it will pay off in the final exam.